So we're going to start looking at capacitors in a bit more detail than you did in National 5. In National 5, really what you saw about capacitors, you said that they store charge, and it takes a little bit of time for the charge to build up on the plates of the capacitor. So we're going to look at that in a little bit more detail in higher, and we're going to come across some equations that are related to capacitors. So a capacitor stores electric charge and electrical energy. And a simple form of capacitor is just two parallel plates separated by an insulator. And the insulator affects how good a capacitor something is. So insulator could be air, wax, oil, or perspex. Many of the capacitors, if you see a capacitor in the lab, will be cylindrical shaped, and that's because the two plates and the insulator in between them are sort of rolled up, and you can see in this diagram here, and then they're shoved into that cylindrical shape there. So you've got two plates, in this case aluminium, anode and cathode, and then you've got something in between them, in this case paper, that then are then rolled up into a cylindrical shape. So in a second I will link you to a video of an experiment showing that how the voltage affects the charge built up in a capacitor. So what you do is you set up a circuit. So you've got a variable power supply, so it could be one of those big long yellow boxes that we have in the lab, connected to a capacitor. And you'd also see there's a switch here. So that switch can either be connected to the power supply like that, so that's charging the capacitor, or it could be connected to a coulomb meter, that's a C in the circle, which basically shows you how much charge has built up on that capacitor when it was charging up. And so what happens then when you move the switch to this side, the charge flows through the coulomb meter, and the coulomb meter tells you how much charge was in that capacitor, how much charge that capacitor could hold. So we're going to charge the capacitor. And to do that, you move the two-way switch towards the battery, so the way that it is in the diagram. And then we wait a few seconds for it to fully charge. Then you discharge the capacitor by moving the switch towards the coulomb meter, so basically changing the switch so it's there. And that means it will discharge through the coulomb meter, and the coulomb meter will then tell you how much charge was stored in that capacitor. And you record the charge stored by the capacitor for 5 different values of voltage. So in this case, if you use the yellow boxes, you could use, in fact, you could start with 0, because you know that that's going to be 0. Then you could go for the 1.5 volts, then 3, then 4.5, then 6 volts. And what you're going to do is you're going to connect the battery at various different voltages to the capacitor, charge them up, and then wait a few seconds, then you discharge it through the coulomb meter. The coulomb meter will tell you how much charge was stored in that capacitor. And then you move to 3 volts and you do the same. So you charge it up, wait a few seconds, wait for it to fully charge, then discharge it through the coulomb meter, and the coulomb meter will tell you how much charge it stored that time. And you're going to do that with 2 different capacitors, the same voltages. So it'll still be 0, 1.5, etc., etc., 3, 4.5, and 6 volts. But the charge will be different because you've got different capacitors. And then you're going to draw graphs of charge against voltage for both capacitors on the same set of axes. So I'm going to pause there and let you watch the experiment.